So very good afternoon to one and all. In second unit, that is in CS 8080 Information Retrieval Techniques. So I am Karthik from Konganadu College of Engineering Technology from the Department of Computer Science and Engineering. So today we are going to see about Information Retrieval Techniques second unit, right? So in first unit, we have seen about the basics of information retrieval. So why we have to use information retrieval in our normal day-to life, and what is IR system, how the web has changed our search to the recent years in how we are using different kinds of searching patterns we are using, and all we have used, how people started to search their informations in the internet, and all we have seen. So next and second unit, we are going to have what different kinds of models are there in information retrieval. So, and what are the different kinds of parameters and probabilistic model, latent semantic model, how different types of informations are retrieved from the basic models in IR system, and we are going to see that. So first, what is a information retrieval model? The IR model governs how the document and how a query are represented, and how the relevance of a document to a query is defined. So first we have to see how the model is retrieved. What are the different types of models we are going to use? So there are three types of main models in IR system: a Boolean model, vector space model, and probabilistic model. So generally, what is an IR model? So we have seen what is IR, and we have seen the different types of models are there. So Boolean model, vector space model, and probabilistic model. So each term is associated with a weight. So given a collection of document D, let that the vocabulary equal to T1, T2, T3. So a word may contain number of terms, right? Be the set of distinct terms in a collection where T1 is a term. So example, if you are going to retrieve a term from the Google, so it consists of a vocabulary that is V, it is represented as V, and it contains different terms. It will not contain one term, it may contain T1, T2, T3, and n number of terms will be there. Be the set of distinctive terms in a collection where Ti is a term. The set V is usually called the vocabulary of the collection, and V is its size. So that is V denotes the number of terms in the document, and D is represented as document. For each term is assigned with the weight here. So an IR model is a quadruple that is consists of the following terms. So first it is D. It is a set of logic views for the documents in the collection. So Q is a set of logic views for the user queries. So Q is a term that is the query. What I should type in the search engines, that is query. So F is a framework for modeling documents and queries. So what documents I should be retrieved, that is D. For that, what query I have to give, that is Q. For this to what model I should, what framework should be used, that is F. And based on that, you will get some results. That results how it is arranged based on the query and what document you have retrieved, how the ranking has been done. So example, without ranking, there will not be anything. How? Because the content we have retrieved, it is not one content, right? It is multiple contents. So how should display that? Which should be displayed first, which should be displayed second, and which should be displayed third? This has to be done. This is called ranking principles. So these are the terms should be used in the information retrieval techniques, and it should be more important, right? So for that, what are the models are there? uh, that is a Boolean model, vector space model, and probabilistic model. So before that, we will see this diagram. This diagram denotes our text document. As I said before, see this diagram. We have an unstructured data in our information retrieval. So you may retrieve text links, you may retrieve the text content, links content, multimedia contents, on what audio files, video files, source code, XML files. You can retrieve whatever the content you want in your system. because it is purely unstructured data. We are like in DBMS, we are not going to use structured format. Here it is of fully unstructured data, right? The unstructured data in the sense, you can type any, you can retrieve any part of the information. So example, if it is text, we can have semi-structured data and this classical model data. Under text, we have these categories. It is semi-structured data and unstructured data. And unstructured data, we have Boolean model, vector space model, and probabilistic model. Under Boolean model, we have fuzzy, extended Boolean, and set Bayes principle. Under vector logics, we have a generalized vector, latent semantic indexing, neural networks. And probabilistic model, we have BM25, language model, difference from randomness, Bayesian networks. This is structured information. For structure, we have these three types of algorithms. And for links, we have a, that is a web page, that is a page rank, and hubs and authorities. And for multimedia, we have image retrieval, music and audio retrieval, and video retrievals. So these are the main classifications of informations which can be retrieved in the IR, that is text, links, and multimedia, right? All this category will comes under this. For that, we are going to have what kind of models we are going to use in IR model. So here, when we are considering IR systems in information retrieval, you can type whatever content you want in the Google. So we are here, we are not going to use structured format, that is, we are not going to use query. Here all it is considers unstructured information. So unstructured in the sense, you can type whatever content you want. Google lo poite we can type whatever we want, definitely you will get an answer. So there we cannot apply structured part, we should apply only unstructured part. Because somebody will type some other content, another people will type another content, so how this data will be retrieved. So that is different kinds of algorithms we are used. And we have probabilistic model. Generally, what will say probability means, what will say, you will say what is number of event occurs. Here we are going to find how many words should occur in a particular document, what is the relation between one word and another word. Based on that, how we retrieve that results, or we are going to see in this particular models. So this model is important. So compared, when you are considering information retrieval, the concepts is purely from CSE, that is computer science, and how we implemented that practical implementation will be of mathematical logic, right? So first, Boolean model. So all these notations are important. That is T document, Q query, F framework, R, that is ranking principle. Ranking will be taken between query and document. What query you have given and what document it has been retrieved and how it should be displayed. So for that only ranking principle. So first one, Boolean model. The Boolean model is one of the earliest and simplest information retrieval model which has been used at the very last earliest stages. So it uses the notation of exact match to match the document to the user query. So both the query and the retrieval are based on Boolean algebra. Here we are going to use Boolean logic. That Boolean logic will have this type of informations, right? So in the Boolean algebra, Boolean model, documents and query are represented in terms of in set of terms. That is, each term is considered present or absent in a document. Here we are going to find exact model. This Boolean model consists of exact model. That document should be present, then only it can be able to retrieve. So it uses exact model technique. Example, it uses the queries, that is, it is framed by Boolean queries. So query terms are logically combined using the Boolean operators and or not, which have their usual semantics in logic. That a Boolean query is a prices semantics. For instance, the query X and Y and not of Z says that a retrieved document must contain both the terms X and Y, but it should not present Z should be not present. So you have to frame the query like that. If I want to retrieve some objects, it should present the query as like that, X and Y and not of Z. Says the retrieved document must contain both the terms and X and Y and not of Z. Another example, the query example expressions X or Y means that at least one of the terms must be present in the each retrieval document. So I have to use the query like that. Here in the first query, we have used and symbol. So and symbol எப்போ வரும்? According to truth table, each value should be present. That is in truth table 1 into 1 equal to 1. So if I'm giving any topic X and Y, that all should be present in the document. Then only you can be able to retrieve that content. So we have to frame the query like that. Instead of that, we can use or also. If I use or, either X or Y, ஏதாச்சும் ஒரு term present ஆயிருந்தாலே I can be able to retrieve. Example, if I'm typing information retrieval, so X will be present in X information, and Y, instead of Y, information retrieval will come. So document la wherever we have X and Y, information retrieval, ரெண்டு word எங்கெங்கெல்லாம் சேர்ந்து வருதோ, that document will be retrieved from the database, and not of Z should be there. So ஏதாச்சும் ஒரு word நான் தேவையில்லாத word வந்து I can give one as Z. So based on that query, I will retrieve the document. So how I will retrieve? I will get information and retrieval in my database. Wherever there is a information next to retrieval, these information would be retrieved. If I give or, what will get? Either information or retrieval. ஏதாச்சும் ஒரு word if it is presented, then I will get. So in this time, I will get huge number of documents from the databases, right? So based on that, we have to frame a query which is satisfied to our results. எனக்கு என்ன results வேணுமோ அதை பேஸ் பண்ணி I will form that Boolean queries. So given a query, the system retrieves each document that makes a query usually true. So that the retrieval is based on binary decision criteria. That is, a document is either relevant or not relevant. So here we have only two options. Either you retrieve the document that is true, that is exact match, or not match. Either two results only possible. So example, how the document is being represented in Boolean model. So in the Boolean model, terms and queries are represented as a set of terms. That is, each term is only considers absent or present in the document. If it is present, here the weightages is add as 1 in the document. That is, weightages ij is the position of the word where it is present in the document. So 1, if appears in the document, it is dj. 0, it is otherwise. So if the particular term is not presented, you will get 0. So this is in this way only the document is being represented in the databases. So for what example drawbacks of a Boolean query Boolean model is no ranking of the terms is provided. At the very first stages only Boolean model has been used. So here there is no ranking principles. So when the first time net has been introduced, the data is very very small amount in the databases. So at the time we have only limited number of model, Boolean model and vector space model. These models only we have considered. So at the time we does not have any ranking principles. So அந்த டைம்ல வந்து நம்மளுக்கு ranking principles வந்து we not necessary, தேவைப்படல. So these information Boolean queries framed by users is often much too simplistic. These queries are somewhat ரொம்ப simple. It is, you cannot retrieve much complex queries. So based on that, you cannot able to retrieve complex data. You can retrieve only small amount of data. So after that, they have introduced one concept that is called term weighting, that is term frequency and inverse document frequency. So we have one term that is called term weighting, term frequency. So what they have said in this pattern is In 1990s, 1920, after the development of internet, the database content very small. ஏதாச்சும் content வந்து retrieve பண்ணணும் அப்படின்னா we can able to retrieve very easily because the database, the content which is present in the database is very small. Okay, so after 2000, 2005, after that, certain years, after certain years, there is a probability, there's a problem that how the data is retrieved. நம்மளுக்கு content, it is more added, so it is more added in the database. So term frequency, it is uh, how this is term related. So we added some extra technique that is called weight. So or particular, in a particular document, how many times a word is being presented, for that we started to assign a weight. So example, if I'm retrieving a document, if that's a word information, I'm going to retrieve information retrieval, and if it is present in more than 10 times in a document, I should add more weight. If I find one word information அப்படிங்கிற ஒரு word பார்த்தேன் அப்படின்னா I will add one weight. If I find second time, I will add two weights. Third time, three weight. Fourth time, fifth weight. So number of times a term has been repeatedly coming in a document, that is term frequency. And based on that, and ranking, automatically that document will comes in the rankingly first. So example, if I'm assume that if I'm going to type information retrieval in Google, so what will be the first link? Actually வந்து information retrieval அப்படிங்கிறது நான் கூகுளில் போய் கொடுக்குறேன். What link I will get the first? Either information retrieval அப்படிங்கிற word may be present in the link itself, or the document which has been retrieved first may contain so many information and retrieval words. So that has been ranked so many times, so automatically it comes first in the web pages. So we like to find score in a frequency terms. We started to find score between query terms and document. Based on that, weight has been given in the document. So the simplest approach is, it is to assign weight to be the equal to the number of occurrence in the term t in a document. So ஒரு time வந்து ஒரு term வந்து ஒரு documentல how many times is being presented, for that we started to give weight. If it is more time presented, then we give more weightages, right? So this weight scheme is referred to as a term frequency, and it is denoted as TFTD, that is term frequency between the term and the document, which is the subscriptions denoting the term and the document in order. For a document D, the set of weights determined by the TF weights above may be viewed as a quantitative digest of the document. So this is the formula. We have another terms also, that is inverse document frequency. If we find weight, we have to find reverse weight also. Suppose a particular word, example, if I started to retrieve a word that is called awkward, and awkward அப்படிங்கிற word வந்து it is very rare. We won't use very rarely in our databases in document. So if particular words present minimum time, it will have weightages also. So normally, if information அப்படிங்கிற word, it will be come repeatedly, or compute, or weight, document, these kind of words will come occurrence. இந்த மாதிரி these kind of words will come repeatedly in the database. But awkward, but certain types of, few example in English, there are so many peculiar words that will not be repeatedly comes. So that kind of words, very very peculiar words, will have reverse weightages. So if it is find minimum time, you can add more weightages to that document. So we can assign weights also. In reverse time also we can assign weights. So that is term frequency and inverse document frequency. So for to calculating this is the formula. And for term weighting frequency, we can have the weightages, and we can assign a weight to the each term to a weight, and a weight has been calculated in a document. So for that, this is the formula for finding the term frequency and inverse document frequency, which is equal to term frequency into inverse document frequency. What is the relation between term weighting and term frequency? So After that, there is a cosine similarity. Cosine similarity in the sense we started to find difference between a similarity between two words. So in mathematics, we have one formula, that is cosine formula, how to find a distance between 2 points. So we'll calculate x1 and x2 value. We'll find x2, x1, x1, y1 and x2, y2 value for a distance between 2 points. So here, this distance between 2 points is, it's a measure in the terms of similarities. If a word is present, what word the next word should come? If repeatedly comes, what's the similarity? Example, if I typing some information in Google, next what word should come? Example, if come retrieved, why should retrieved comes repeatedly in a document in a database? So for that, what is the similarity? So there is cosine similarity. So in second unit, we are seeing trying to find different types of models, and all these models are related to our search engines, how this information are being retrieved. ஒரு வேர்ட் நம்மளுக்கு ரிட்ரைவ் பண்ணோம் அப்படின்னா அந்த வேர்டுக்கு வந்து என்ன மீனிங் இருக்கு, எப்படி அந்த வேர்டு வந்துச்சு, வாட் ஹவு த டாக்குமெண்ட் இஸ் பீயிங் ரிட்ரைவ். there are so many patterns under that. So this is the formula for that. So cosine similarity, I will tell you the formula. So in second unit, there are different types of models. So we have seen about basic IR models and Boolean models. Okay, thank you.